Hey, everyone sign. Cool. Okay, let's get started. So this is a workshop for Introduction to Julia. This is part one. There's going to be a part two later in March. So this is going to go over like super conceptual and just what are the advantages and disadvantages of Julia and what it's used for. We'll be doing some basic setup. Does everyone here have VS Code? VS Code? Okay. Do you? Yeah. Partner up then. Okay. Yeah, let's get started. So what is Julia? Does everyone here have like a basic understanding of like what Julia is at all? Somewhat? It's basically a programming language that's very high performance and it's faster than Python, but it has the capabilities of like Python as well. So it's mostly used for data analysis, a lot of simulation and making neural networks, models, things like that. It has a lot of uses, but people mostly use it for data analysis because it's very fast and it can handle large amounts of data. So why is Julia like really good and why do people use it? So Julia is very useful because of the tool language problem. So a lot of engineers or like scientists, they use two languages in their projects. One for just easier syntax and then one for like performance. So for example, you use Python and then Fortran, which is a C-based language. But Julia solves that problem by offering both advantages. So its syntax is Pythonic, so it's like basically English, and it's super fast. So it's like both languages put together. So for example, look over here. Julia has all these advantages, but each of these, like for example, C++, like no one uses that for like data analysis or anything like that. MATLAB people use, but it's like moderately, it's like slow, it's like fast, but not really. And it has, we'll be going over all this, but it has all these features and advantages that some languages do, but they don't have all of it. So that's why people use Julia a lot. So for syntax, it's very, very similar to Python. Like, I'm guessing most of you here know Python. Does everyone here know Python? It's basically Python with like slightly different syntax, like in some cases. Like for example, you can define variables here, but you can also do explicit definition like you do in C++. So if you want to like make it more stricter, you can do that. And like just addition, subtraction, basic math, creating an array, this is basically Python. It's essentially Python with like slightly, like for example, printing, instead of like just print, it's println. So it's not that different for syntax. If you know Python, you know Julia. It gets more complicated, the syntax does differ, like the more advanced techniques you do, but even then it's still very Pythonic. Like if you know Python, you know Julia. So what are the core features of Julia? So we'll be looking at like a couple core features. There are more features, but these are like the base. It's like the base that the other features are built on. So this has just-in-time compilation. So essentially, it compiles machine code and then runs it using LLVM, which is like a type of technique. And it makes it faster than like interpreted languages. So for example here, this is Python and this is Julia. The first execution is similar to Python, or I guess in this case it's faster. But after that, like the subsequent execution, like it's way faster. Like it's literally like 100 times faster, I think. But that's why people use Julia. It's very fast, like incredibly fast. because of just-in-time compilation. So that's one of the core features there. The next core feature, multiple dispatch. C++ has something similar, but let me explain this first. So basically, you can have two different functions, almost exact same functions, but it has, or exact same name, but it has different parameters, and you can have different things inside too. C++ has something similar, but you can only change the parameters. It's called function overloading. It's similar to multiple dispatch, but first of all, you can only change parameters in C++. You can change like the actual logic, I believe. And also, for C++, it runs at like before runtime. I believe it compiles and then runs. So it chooses which one and then runs. But Julia, it just automatically does it there. Like if you call it, it doesn't go back. It just compiles it at runtime. I can go more on that if that's confusing, but yeah. But you can see here, that's the output here. So if you put like an extra input here, then it's going to choose this one. If you only have one input, it's going to choose this one. But it's the exact same like name. So you can use it for like methods and things like that. So another feature is built-in parallelism. So this isn't explicitly seen here because it's pretty simple, but this add threads keyword, what it does is if you have multiple CPUs on your computer, like this has one CPU, so it's not gonna do much. But if you have like 4 CPUs, it spreads the workload accordingly. Like here, it's iterating from 1 to n, and n here is the 1 million. So that's a lot. So what it does is, for example, for the first CPU, it would just iterate through 1 to 250,000. And then the second CPU, it'd be 150,000 to 500,000. But, so it is at the same time. So, like all the 4 iterations, there's 4 CPUs, it spreads it accordingly, and then it runs at the same time, like asynchronously. Node.js, if you're familiar with that, JavaScript kind of does that, but JavaScript also doesn't have the advantages Julia has. So Julia has like a bunch of features, just put in it, and it makes it super fast. And this is one of them. So, yeah. So another core feature is it has like the classic scientific computing and things like that. You can do integrals. This is a very basic example. It's not even an integral, it's like a function. But there are like a lot of libraries you can use for integrals, plotting. It has all the basic stuff. So, and it's fast. So it's fast, and it has all the libraries built in for scientific computing, which is it's a really big advantage. But yeah, you can do linear algebra, differential equations, and machine learning that comes in here too. So there's a lot of that. Interoperability. This is my favorite, like, I guess, core feature. This is very simple. It's just calling C, like a kind of a C command, but it can call multiple languages, like within its syntax. Like if you can put Python code, you don't have to like translate it to Julia. You can just put Python code and it'll run it. It can run C++ code inside Julia. So I think you can do C++, you can do JavaScript, Fortran, and you don't need to change syntax. You can just run it by itself. That's it, no translation. So that's a very big one, because a lot of enterprise like systems, they use their own language. Like they're not gonna switch the entire thing to Julia because it's a lot of work. So you can just use Python and just put it in the Julia script, and you would have to do like a couple libraries, you would have to install a couple things, but it would not be that hard.
What's the call for that?
So I think it's PyCall. That's the library they use. I didn't want to like go into that too much because it's just the beginning. Yeah. So who uses Julia? A lot of companies use Julia. I believe last semester there was a Johnson & Johnson alumni intern who said they use Julia for a lot of their data processing. His Python was too slow. So Python is as people say, Python is kind of a fast language, but it's one of the slower languages out there. So Julia covers it. So for example, NASA, Johnson & Johnson, and Amazon, I'll be going into more like in depth. But a lot of research institutions use it as well. So NASA, they use it for a lot of purposes. So exoplanet analysis, so like planets outside of our solar system, you're getting a lot of data because it's space. Space data is like a lot of things, so like temperature or like what kind of minerals are there, whatever like data you get from there. It's a lot of data. So TRAPPIST, that's one of their missions. They get a lot of data from that, and they usually for the data processing for that. Cosmic microwave, like radiation, that's like a lot of data points because it's radiation. Like there's a lot of points in in space, and there's a lot of like data points there. So you can analyze cosmic microwave background data, and that's how they figure out how early, like the early universe formed, Big Bang. Like explaining science right now, but it's a lot of data, and they use Julia for it because it's super fast, and it can handle large data sets. They can also do simulations. That's what I was talking about. NASA uses it for like building spacecrafts and like figuring out if this part is safe, if this engine is safe, things like that. And it is very good at what it does, so it ensures mission success and safety for that. So Amazon, this is like what I wanted to go into more. So Amazon leverages Julia for its like quantum computing initiatives and machine learning. I also talked about this before. Julia is used for machine learning, and for quantum computing, it's very fast. So quantum computing does go into that. So Amazon has a service called Amazon Braket. So it's a fully managed quantum computing. They have like a bunch of servers that people can just do quantum algorithms and things like that. So that's just one of their like services, but they built a Julia extension to that service. So if you know Julia, you can also use Braket. Because Amazon Braket, it's like a UI service, but if you know Julia, you can go more specifics, things like that. So it's called Braket.jl. So they literally build quantum algorithms, and you can test it, design it, and just run it on their service. And the second one would be Amazon SageMaker. So this is their like machine learning. I guess it's like UI also. It's like machine learning. You can build models using this service. You can use a lot of languages here because people use Python because that's more used for machine learning. But they recently added Julia support as well. And some of the advantages of using Julia over Python would be, for example, like I've said this multiple times, high performance computing. So you can like train your models faster. You can train more models, like multiple models at the same time, things like that. It's also very like managed. It's very like compact, so you don't have to like worry about getting a lot of tools to use Julia or anything like that. If you know Julia, that's all you need. You might need a couple like the libraries here and there, but it's very like seamless. But yeah, both of these programs use Julia for different purposes, and they use different core features. But at the end of the day, they both use Julia because it's very good and it's very fast. That's the main reason. So yeah, Johnson & Johnson, I was talking about this before. They also have a lot of simulations and things like that. So for example, if there's like a new drug and they can simulate how it would perform or how it would affect like the human body, they have simulations for that. They use Julia for that. And they also do predictive modeling. So machine learning is also used in Johnson & Johnson. It's used to predict like drug efficacy and safety. I think Pfizer also uses Julia. I don't know if they use it during the COVID-19 pandemic, but they currently use Julia definitely. And so it's becoming more and more popular. So the question is, should you use Julia? So Julia does have a lot of advantages, but there are still some factors worth considering to know if it's the right language for your projects. Like for example, it's very fast, it's very good at processing things, but the package ecosystem is still growing. So like Python definitely has more support and it has a bigger community because it's been out for like 20, 30 years. This came out in 2015, so maybe it has like 10 years of support. And Julia's just-in-time functionality can be detrimental because, for example, if you're doing like an automation script, so if you're just running a program once and that's it, you want your first execution to be fast. But if you're running it multiple times, yeah, first execution and then it runs faster like the second time. But if you're only running one script just to like input data or anything like that, that's going to be detrimental because it's supposed to be slow. Julia also has limited support for web development and GUIs. That's a really big disadvantage for Julia because Python has really good support for web development and a lot of websites and web applications use Python. Julia does have support for web applications, but it's definitely not in the same level as Python. And like I said, Julia's community is still small compared to other languages like Python and R. So there's like a couple forums here and there. It is growing, but it's still in its infancy. So for example, if you have an error and you go online, there is some support, but it's still like a little, you would have to dig deep to get into the errors. Also another thing I didn't put here, Julia is, like I said, it's very new, it came out in 2015. There's a lot of major bug fixes they do all the time. So sometimes things just break. Like some of the libraries, they just sometimes break, or they have like inconsistencies, or the syntax will change, or something like that. So you would have to keep rearranging and like redoing your code, because they're still going through major fixes. So that's like some of the biggest disadvantages, but it is getting better, and it's getting more support. It's getting more support for web development, and like the community is always growing. But right now, currently, this is some factors worth considering if you're going to use it on your project. What I would use it for mostly would probably be like data pre-processing, maybe building models. But I wouldn't use it if you're gonna like input data into like web application, or if you're using a lot of like enterprise tools, because it doesn't have a lot of support for that. And enterprise tools would be like for example, I think one of the examples would be Jira or anything like that. But yeah. We're gonna do more things, but this is the question slide. You guys have any questions so far?
You said that it works with ML, so does it also work with Jupyter?
It does work with Jupyter, but it's a hassle. Because VS Code has more support for it. But for Jupyter, you would have to, because I've tried doing it, that's why I switched to VS Code for this workshop. Jupyter, you would have to install a bunch of files manually and put it into the folders, and you would have to like switch the kernel and things like that. It's a little bit more of a hassle. But for VS Code, you just have to enter a command in the terminal, and then I think add. We'll be setting up Julia like the next slide, but it's way easier on VS Code than Jupyter. That's like another reason.
No, I know. Yeah.
That's like another reason. That's another disadvantage. Because like I said, it isn't. It's not like entirely supported in all the machine learning things, machine learning softwares like Jupyter Notebook or Google Colab. But yeah. Okay, let's set up Julia. So, who has VS Code?
Oh, I got it.
You got it?
I got it.
Cool. So, first of all, I'll just go through it. Let's make a new project. So what? I don't know what's add. There we go. It's fine. Are you guys on this week? Okay. So first of all, just do open folder and just make a new folder, so you can like more organized. Wasn't an experiment. I don't know. Can't do it on here, but do you guys know how to open the terminal there? There should be a terminal on the top and on the taskbar, and there should say new terminal. Oh, it's doing that. That's so good. If you go here, new terminal, there's new terminal. Are you guys all in the Discord? Let me just bring it up here. So just type that into the terminal over here. It should say whatever you named it. Like that's your root file, and this is the actual file. Type this over here, and it should take a minute. But after like you guys run out, let me know. Can you guys see it? Very cool.
Is that just installing it from like the store that they have?
It's the I didn't even know you could do this. It's like the Microsoft Store. You can it has a command for it.
Really?
Yeah, I didn't know that. But you could technically just install like the actual files from the store, and then add it to your notepad.
Yeah, it's good.
Hmm?
They have like an install library.
I think so. Yeah. I mean, I just did this because it's way easier. But supposedly you can also install it just straight from like a Microsoft Store. But yeah. Is it still running? Do you guys have any other questions?
Will it show up on your extension?
I'll tell you after that how to check. But after it runs, let me know.
Yeah, it should show good.
Okay. Because I also did it like how you did it. Like it just like.
Like it gave you the everything.
Oh, okay, no. This is just that's just like tools. That's not good. That's just tools. So do that still.
I already had it installed. But like
You can do it again. I mean, then
the Julia like.
First you like this.
Oh.
So I'm gonna like that. Oh, I need to know. Can you just type that on?
For this.
You got it from here? Yeah.
Is that weird?
It's the same thing.
Okay, why did I do this then?
Wait, but did you install it?
Yeah, yeah.
Like locally, or in one folder? Do you know?
Uh,
Okay. want to check, type Julia and then dash dash version. And if it's there, it should say the Julia version.
I don't know.
Oh. Oh. Did you make any folder? This is what I'm making.
Yeah, it's fine.
Okay. It's got my name. Something else, I guess. Yeah, that's fine. Yeah, there's a lot of.
I guess
It's fine, it's
doing
fine.
it, but
It's because it's part of the Microsoft Store, and on Microsoft Store you have to like select permissions and stuff. That's what he's doing, but it's just making that.
it sounds like it's really fun.
I said this for fun, because I didn't want to mess it up.
It's good. Yeah.
That's fine. Oh, it's good.
Oh.
No notification. It's very sensitive. Yeah.
Okay.
It's actually cool, isn't it?
But let me know when it's like done running for all of you. Is that right?
Yeah.
It takes a minute. Just press yes or like Y for all of them. If it asks you. There you go.
You go.
Yeah. Thank you. Is it done for all of you?
That's good.
After that, go to where are settings? Extensions, and then type Julia in here, and then install that as well, because that's tools for Julia. So, like for running servers and things, because you can't just for Python you don't. I mean you can, but you don't need a server or anything. But for Julia you do kind of. Oh yeah, all these files, I will be going over them. It's just to like show the core capabilities, like I said. It's like the exact same code, but we're just gonna be learning them. This should all be in the GitHub for the workshops. But if you guys don't know where that is, let me know. I can just show you. When you are done installing that as well. You didn't say this. Did you get okay. Okay. Now do Control Shift P and a thing should pop up over here. Like a search bar. and type Julia start REPL. Mine is already running, so it's not gonna do anything. But there should be like a message over here that says like, oh, it's starting, or like it's starting a language server, or something along those lines.
Like that.
Oh yeah, yeah. Supposed to be there.
Wait, why does it need a server?
Not entirely sure, but I think it's because, like for the, what is it? The interoperability, where it uses like different languages, like you can add different languages to Julia. I think that's how it does that. Because it has a server, so you can use switches. It's pretty dynamic. You can do a lot of stuff with it.
That's a really crazy,
Right? I know.
like,
it's-
technique, I guess.
Yeah, because you can just have Python code and then C++ code.
I can't,
Or
I can't wrap my mind around that.
I know. It's quite insane. I don't know if it's good practice though, because it's like,
Does it work correctly?
yeah, it works, but it's just like it's very confusing. Because like other people are looking at it, because they're like, oh, they're looking at Python, and then just switches languages. But I mean, sometimes you need to do that. Everyone's is different.
Oh, you just do it every day.
Yeah. Okay. Over here. So the extension for Julia is JL. So just do a new file. And then just type like whatever you want to name it. But after that, type JL. So let's see. Let's just do how it works, just for now, just to see if it's running. It should be running for me, but for you guys, I just want to make sure. Do Control S save because VS Code stuff sometimes like that. For that, run code right over there, top right, and it should run it right over here. We're good?
Oh, this is just.
For now, just
Yeah, well,
little more stuff. You see my Christmas topic? What?
Huh?
oh,
It's not jail. Just do a little over it. Do it.
well, I never do it. Do you ever write, like, I never write hello world.
I mean, if I'm doing like a new language and I'm setting it up, I'm like, does the print statement at least
It's like a
work?
thing that, right? You're supposed to.
Yeah, that's how you like. It's common practice because once you set something up, something always goes wrong. Like especially with Python, because there's like different interpreters and shit like that. So once you like set something up, just do like a simple like a print statement, just to see if it works. It's common practice for me. I'm learning
I know. I
language.
think it's like a precedent to write "Hello World" for some reason.
Oh, like why it's hello world?
Yeah.
I don't
yeah,
know.
yeah.
There's probably a reason for it, but I don't know. Okay. Did it work well? Oh, it's printed. Yeah, you have to be. That's like a. Because that's an L. It's print L M. Just want to make sure. Because I made that exact same mistake. I thought it was an I. Okay, let's just look at some things. We've looked at the syntax a little bit. Like function definitions. I think this N, that's a difference from Python, but it's mostly the same. I think this is like doing functions just with one line. Python also has that. But they have tuples, they have all like the basic data structures, they have stacks, queues, all those things. But it's just the syntax is slightly different. But let me go over here. Okay. So I want to show you guys like in real time, like how it is. Like the speed here. So the first execution, now it's even longer. It's like almost 0.1 seconds, which is kind of long for like actually printing something, like or actually doing an operation. But after that, it's 100 times faster. So first execution, it's like this same. It's like the normal amount, and then after that, it goes way faster. Because it does the same thing C does. So it like compiles first, and then after that, you already know what it's doing. So it already saves it, and then just runs it faster the next time. You don't have to like read the machine code, because you already have the machine code. So it saves it, and then you just run it. For Python, this is also doing almost the exact same thing, but you see, that's almost 0.4 seconds. So Julia is way faster. So multiple dispatch. This is the exact same thing, but I just want to do more into it. So yeah. First call, it only has the area and then 5.0. So it would just use the top function. The second function has length and width. So it's entirely different parameters. Like there's not even a radius there. Because that's for circle radius and this is for rectangles, whatever you want to call it. But yeah, if you put in different parameters, it gives different functions or like outputs. A lot of people use this for, I mentioned methods before. So for example, have you guys taken VSA or Proc 2 here at all? So in Proc 2, I don't know if you guys did this project. There was like, I believe there was like a car salesman or something along those lines. Yeah. So you know how there's like different methods, and sometimes you would have the same method, but it's slightly different, like the parameters are different. And I believe you did that in C++. That's operation overloading. So that's similar to this, but how it works is slightly different. Like this runs at, this executes at runtime, which is right before it produces output. But for C++, it compiles it first. So it first chooses the function, and then it outputs. but for Julia, it doesn't do that. It goes straight to runtime and then outputs it, and then bases it on what their parameters are.
So it means an end after every function.
What? Yeah.
Okay,
Yeah,
that's like a
it's
little
different
different.
Python. Yeah, it's slightly different. And also like this has like explicit or no, this explicit like type declarations, which is a feature of C++ or C that Julia took. So it's more stricter, I guess. But yeah. I think for Python that's sometimes an issue. Because without explicit declaration, because it just kind of guesses. Like if you put in a 5, it's going to be like, oh, it's an integer. But sometimes you might want a 5.0 or like a 5.02 or something like that. Or like have to be more specific. So Julia has that. You can explicitly declare the type. This is parallel computing. Okay, this is a little bit more confusing, but it's not too bad. So the use based off threads. So Julia has something called threads. So it's basically like how it connects to your CPUs. Let me write this down. This might be a little easier. So for example, if your computer has 4 CPUs, this is iterating from 1 to n. So it's 1 to 1 million. It's iterating from 1 to 1 million. What it usually does, or I guess this is like common practice, you would distribute it equally. So you do 1 to 1,000, then 2 to 1,000. 500,000, and then so on. It's supposed to distribute it equally because that's how it's supposed to work, but that's not what it does. Sometimes this just runs longer than it needs to, or this runs shorter than it needs to. So once it's done, like for example, it could just be like 1 to 200,000, but this just finishes faster. So then it just moves on, or not moves on, but for example, okay, this is another scenario in this, but let's say this has 3 CPUs, or I guess 5 CPUs that have an extra CPU. So once this is done, so like, let's say this is going to, let's say 1,200,000. So sometimes this just finishes faster, right? So then it'll just use this CPU and like do this operation here. Like once it's done, and it'll do this operation here, and then subsequently just do it. So sometimes it's not entirely equally distributed because one CPU is just faster or one CPU is just slower. So it depends on like how fast your CPUs are. But it is pretty customizable too, because you can have like certain iterations be completed on certain CPUs. Threads is like the basic for this, like the threads, based on threads. That's just like the basic library for Julia, but there are more things. I think there's something called spread or something along those lines. But we'll be talking about that in part 2 because it's actually cool. But that's parallel compute. Do you guys have any questions? I know it was a little confusing.
But the CPU is not simultaneous.
It's so when like
said it changes if there's extra room. What is that?
It's like asynchronous, which means all those iterations, it distributes equally, and it's happening at the same time.
So this.
It's simultaneously, but sometimes like a CPU just runs faster. So then it would have to like go on to the next one. Or it's runs slower. Here are libraries. Oh yeah, I guess this is a library. Because libraries are a little more complicated because I have to figure out like an actual good one, but this is a built one. This is a built-in one. It's just a lot of like math functions. But this is just used for like basic math. This is an integral, data function, trapezoidal rule. I guess no calculus. But this is just like basic, like scientific computing. Interoperability. Yeah, this is we talked about this before. That's C code. It's like a very short. It's just like a one function. It's like a built-in like it goes into Julia because it's based on C, so it can obviously run C. But this is like a very basic example. It can run like other languages. So we're gonna run Python, we're gonna run JavaScript. I didn't want to do it now because that's a little more advanced, and I'll be going over that in my suit. But yeah. I think that's basically it. Do you guys have any questions at all? Okay, cool. Part 2 is probably going to be longer, and we're going to be using all our VS Code. Julia, we're going to use Julia to do some practice problems, maybe data preprocessing, or run simulations. But that will be like late March. So it's going to be after spring break, so you guys don't have to worry about that. But thank you for coming. I know it started a little bit late, but thank you for coming. That's it.